Good evening, students. Now, I'm going to derive the capacitance of a parallel plate capacitor. Capacitance of a parallel plate capacitor. Now, initially, we need to consider the two plates, two parallel plates. Plate 1. Now, I'm going to, this is plate 1 and this is plate 2. Plate 1 is charged with positive charge plus. Here you might have seen this plus signs means the plate 1 is charged with positive charges and plate 2 is charged with negative charges. Both the plates are having equal area and they are apart. They are differ by a distance d along z-axis. Now, according to capacitance formula, C is equal to Q by V, which is equal to epsilon. I'm going to use Gauss law here also. E bar dot ds bar by minus E bar dot dl bar. It is a absolute value, so no need to consider this minus value. So step 1. Now, and one more thing, as the charge is distributed on the plane, we need to consider surface charge density as rho s is equal to Q by A. This I am going to use in between the derivation. Step 1. Okay. Now in step 1, initially I am going to find out the E, that is electric field intensity between these two plates, which is equal to, now if you consider the electric field intensity here in this point means, now this point is in between the two plates. One plate is of positive charge, one more plate is of negative charge. So at this point, yellow dot, right? At this point, the electric field intensity due to plate 1 is rho s by 2 epsilon minus az bar. And at the same point P, this is the point P, the electric field intensity due to negative plate is equal to, because the charge on the plate 2 is negative, that's why minus rho s by 2 epsilon, the direction of electric field intensity at the point P due to negative plate is towards plus az, whereas the electric field intensity due to positive plate is towards negative z-axis. This is equation 1. Now, both are combined, minus, right? That is minus 2 times of rho s by 2 epsilon a z bar, which is equal to 2 gets cancelled. We left with rho s by epsilon a z bar. This is equation 2. Step 2. I'm going to find out the potential at this point P. That is, potential means V. I need to calculate V. V is equal to minus 0 to D, because this is the 0, this is the height is D. The difference between these two plates is small d. Now, as per the definition of electric potential, in order to find out the electric potential at P, I need to do some work on a unit positive charge against the electric flux, which is in the top to bottom side. That is why I need to do work against this electric field. That's why 0 to D, I have mentioned the limits. Now E means here is rho S by epsilon Az bar dot, because I need to consider this formula. DL means that is along the z-axis dz into Az bar, which is equal to minus 0 to D rho S by epsilon Az bar dot Az bar 1, that is dz. After substituting the limits, I'm going to get V is equal to rho S by epsilon into D. Now, substitute the results of, this is the equation, substitute the results of step 1 and step 2 in step 3, yes, which is equal to C is equal to Q by what? V. What is V? V is equal to Q by rho S D by epsilon. Substitute, which is equal to, what is the value of rho S? Initially we have considered here. That is Q by A. Q by A into T. The epsilon will go to numerator, which is equal to this Q gets cancelled. We left with epsilon A by D, which is equal to capacitance C. C is equal to epsilon A by D. This is equation 4, which is nothing but capacitance of a parallel plate capacitor. Thank you, students. Thank you very much.